Good morning, students. This is the coordination compounds chapter, and I'm going to start with the nomenclature of coordination compounds, which is a very important topic. So first of all, let's start with the formula of mononuclear coordination entities and how to write the formulas basically. So there are some rules which are applied while writing the formulas. The first rule is basically the central atom is listed first. सबसे पहले हम central atom को लिखते हैं जब भी coordination complex आप लिखेंगे. And ligands are then listed in the alphabetical order. And the placement of a ligand in the list does not depend on its charge. So it depends on the alphabetical order. The polydental ligands are also listed alphabetically. In case of abbreviated ligand, the first letter of the abbreviation is used to determine the position of the ligand in the alphabetical order. पॉलीडेंटल लिगेंड है, एब्रीविएशन यूज़ कर रहे हैं तो भी आप एब्रीविएशन की उसको भी मतलब क्या करेंगे, अल्फाबेटिकल ऑर्डर लगाएंगे फर्स्ट लेटर को देख के. नाउ द फॉर्मूला ऑफ द एंटायर कोऑर्डिनेशन एंटाइटी वेदर चार्ज और नॉट इज इनक्लोज्ड इन स्क्वायर ब्रैकेट. अब जितनी भी कोऑर्डिनेशन एंटाइटीज़ हैं आपकी, फाइन, वो सारे आप एक स्क्वायर ब्रैकेट में लिखेंगे. लिगेंड्स अगर पॉलीटॉमिक हैं उनको पैरेंथेसिस में लिखेंगे, मींस कॉमन ब्रैकेट्स में लिखेंगे. नहीं है तो आप बिना ब्रैकेट के ऐसे ही लिख देंगे. एंड लिगेंड्स एब्रीविएशंस आर आल्सो इनक्लोज्ड इन द पैरेंथेसिस. अगर एब्रीविएशंस यूज़ कर रहे हैं देन अगेन यू विल यूज़ द पैरेंथेसिस. नाउ देयर शुड बी नो स्पेस बिटवीन द लिगेंड्स एंड द मेटल विद इन द कोऑर्डिनेशन स्फीयर. दोनों के बीच में कोई स्पेस नहीं होना चाहिए. व्हेन द फॉर्मूला ऑफ ए चार्ज कोऑर्डिनेशन एंटिटी इज टू बी रिटन विदाउट दैट ऑफ द काउंटर आयन, the charge is indicated outside the square bracket. अगर आप formula लिख रहे हैं without using the any counter ion and if there is some charge, then you have to put the charge over the square bracket, like if positive or the negative in this manner. And the charge of the cation is balanced by the charge of the anion. Fine. And because in the 2004 IUPAC draft recommends that ligand will be sorted alphabetically irrespective of the charge. So this is basically the rule. Fine. Now next is the naming of mononuclear coordination compound. After that I will start with the nomenclature. There again following rules are there for when naming coordination compounds. The very first rule is that whenever you will name the coordination compound, cation is the named first in both positively and the negatively charged coordination entities. So it is the cation which has to be named first. And the ligand are named in alphabetical order. It means ki if cation is counter ion, then you have to write the counter ion first. If the cation is the coordination complex, then you have to write the coordination complex entities first. So basically the cation has to be right first, and the ligands are again named in the alphabetical order before the name of the central atom ion. Fine. So when you will name the complex, then you have to write the name of the ligands first, and in the end you have to write the name of the metal ion. Fine. Now this procedure is reversed from writing formula, and the name of the anionic ligands end with O, which is, or basically you can say IDO. Fine. And those of the neutral and the cationic ligands are the same except water, that is for aqua, amine for the amine, ammonia, carbonyl for the CO, nitrosyl for the NO. While writing the formula of coordination entity, they are enclosed in the brackets. Fine. अगर आप anionic ligand use कर रहे हैं, then you have to write O in the end. Like for the chlorine, you will use the word chlorido. For bromine, you will use the bromido, cyanido. Fine. But in the case of neutral and the cationic ligands, you have to write the name as it is. Like for the water, we use the word aqua in the coordination complex. For the ammonia, we use the word amine, which is double M. And for the CO, we use carbonyl. For the NO, we use the nitrosyl. And again, we have to enclose these entities in the brackets because they're polyatomic. Now, prefixes mono, di, and tri are used to indicate the number of the, in a very important point, like if in the ligand, already the numeric is there, then for that ligand, if it is present more than one amount, fine, then in that case you have to write, instead of bi, tri or tetra, you have to write the bis, tris and the tetra case. For example, if there is a ligand which is the triphenylphosphine, again in the name of the ligand there is a numeric which is triphenylphosphine. So to basically locate this ligand, or to tell this ligand which is two ligands in this coordination sphere, you have to write bis triphenylphosphine, not the bi-triphenylphosphine, because already your ligand has a numeric. Fine. Similarly, the oxidation state of the metal in cation, anion, or the neutral coordination entity is indicated by the Roman numeral in parenthesis. So you have to write the the oxidation number of the metal ion in parenthesis like this in the numeral. And if the complex ion is cation, the metal is named same as the element. If your complex ion is cation, the metal is the same. But if your complex ion is anion, then you have to write 8 in the end of the name of the metal. And sometimes for some metals we use the Latin words, like for the cobalt, we see for the cobalt it is very simple, you have to write cobaltate. But in the case of iron, you will use the Latin word like ferrate. For F you use ferrate. For gold, like for O you will use the word orate. For silver you will use the word argentate. These are the Latin words basically. Fine. And in 2004 IUPAC draft recommends that anionic ligands will end with ido, so chloro would become chlorido, etc. So we will use the suffix ido instead of O. Fine. The neutral complex molecule is named similar to that of the complex cation. Again, अगर आपका neutral complex है तो उसे हम cation की तरह ही naming करेंगे. So these are the following examples which I am considering here. This is the formula which is given and you have to name it. So start from the cation now. The cation is here is the square bracket, and because counter ions are -3, so it means it will be 3 positive charge over this square bracket. So both the ligands are your neutral, so it means chromium must be having 3 oxidation state, and ammonium 3 and water 3 is there. So let's start with the alphabetical order. So aqua and amine both start with A, but A, M and AQ we have to choose A, M. Then triamine, triaqua, chromium 3 chloride. Now this is the second example where you can see the ethane 1,2-diamine ligand is there, and again because numeric is inside the ligand and 3 are there, so you have to write tris ethane 1,2-diamine in the brackets, then cobalt, the 3 oxidation state is there, and the sulfate. Fine. In the next again you can see here this silver which is having the ammonia is the cationic species, and which is cyanide is the anionic species. Because silver is having the +1 oxidation state, and here the ammonia which is the ligand which is neutral, it means the whole of this species is the cationic. So the name will be diamine silver 1, dicyanido argentate 1, because this complex is anionic, and for the silver you have to write the word argentate, which is the Latin word 1. 1 is basically the oxidation number which has to be written in numeric Roman numeral. Now next is the example 9.2. There you can see you have to have the formulas for this. Tetramine aqua chlorido cobalt chloride. You can see tetramino aqua cobalt chloride. You have to write the ligand according to the alphabetical manner. So Am comes first, then Aq, then you have to write ammonia first, then water. Then potassium tetrahydroxide, zincate, then again K2 zinc OH4 K2. So you can see tetrahydroxide means OH4 zinc 2 oxidation state is there. So and 4 OH negative charge is there. The total will be the 2 negative on the coordination sphere. To balance this 2 negative you have to write K2 counter ion. The next potassium trioxalate aluminate, again you have to write it like this, like aluminum 3 and oxalato 3. Then 6 negative charge will be on the oxalato and 3 positive on aluminium. The total will be 3 negative over the coordination sphere, and to balance this 3 negative there is a K3 counter ions, or the potassium 3. Now next is the dichlorido base ethane 1,2-diamine cobalt. This is the neutral, basically neutral. You cannot see neutral, you have to look at the charge basically. So you can see cobalt 3 positive charges there, 2 chlorine and ethylene diamine. This chloride 2 negative, 3 positive. The total will be 1 positive charge over this coordination sphere. Now next is the tetracarbonyl nickel, which is the 0 oxidation state. So nickel 4 carbonyl bracket close. So this is how you have to write the formulas for the following coordination compounds. And now next is the next you have to do the nomenclature for this compounds like this. So just start. So this is basically the neutral complex, so you have to start with the ligands first according to alphabetically series. So diamine, chlorido, nitrito, N, platinum 2 cationic species, because neutral has to be named like a cationic species. Now next is the anionic species. So first you have to mention the cation, which is the potassium here counter ions. For the potassium trioxalato chromate 3. In the next you can see this, again it is the cationic complex, and you have to write dichlorido bis ethane 1,2-diamine cobalt 3 chloride. Now next you can see is again this is the cationic complex. You have to write pentaamine carbonato cobalt 3 chloride. In the next this is the anionic species. Then mercury 1 tetrathiocyanate OS cobaltate 3. The mercury 1 is in the oxidation state 1, because this is the 4 negative and cobalt is 3 positive. Total charge will be 1 negative over the coordination sphere. So mercury is having the +1 charge. So this is how you have to do the IUPAC names for the following coordination compounds. So this is very easy, and this is the index question which is given to you. Just try these questions and you will be able to do this questions on your own. If any problem, you can ask me in the class. So this is how you have to do the nomenclature in the coordination complexes. So first you have to remember the rules, then you have to follow.